Yo, it's only been a few weeks since I shipped my first iOS app with AI. It took me less than 2 weeks from when I wrote the first line of code to when it was approved by Apple and available to install on the App Store. This was all without ever having learned Swift or mobile development before. Now, I am a software engineer and I've been spending the last 3 years learning how to work with AI more efficiently and avoid vibe-coded slop. But even though AI makes this whole process of building apps easier, it won't prevent you from making the same mistake that I did: building the wrong thing. So I'm shipping a second app now that I'll actually use myself to solve my own problem and, importantly, be much more excited to market it, which is all that matters when AI makes it so easy to build things. Documenting the whole process as I try to build apps that can replace my 9 to 5, and in this video, I'll talk about how I'm currently thinking about building apps. So the first place to start when building a new app is coming up with the idea. This is something I overcomplicated for years, and it's the reason that even though I've been learning to code for something like 8 years now, I've only shipped a couple of apps and never made a single dollar with them. I'm hoping to change that this year, but where I was constantly getting stuck was thinking that I had to come up with something brand new, never seen before, and that any competition meant it was a bad idea to pursue. The mindset shift that I've been trying to have is the fact that an app exists means that there's proof people want it and likely are willing to pay for it. So there is a strategy of take an app that you use every day and build a better version of it, whether that means it solves your problem better, the UX is simpler, or you're adding your own unique twist like gamification. Another source of ideas, and personally I think this is the best one, is solving problems that you actually deal with yourself. You can still go on to build an app that you would never use yourself and be successful, but personally I just find that process miserable. My first iOS app that I just launched was a screen time blocker for readers. Basically, it blocks all of your apps until you hit your daily reading goal. This is an app that I thought was interesting to build, but I wasn't using it at all myself throughout this process and hated the idea of having to market it. For my next app, I'm trying to solve my own problem that I've been working out and trying to eat better for years, but I haven't seen the progress I've wanted to. Now, after I figured out what I wanted to build, I spent a little bit of time figuring out how this type of app should actually work. Not just what it should look like, but what real apps do in the parts of the flow you might not think of at first. Things like empty states, loading states, error states, and all of the other micro decisions that make an app feel polished. One of the easiest ways to make your app feel like AI slop is asking an AI coding agent to just generate UI from a blank prompt. I've noticed this over and over again. AI is pretty good at building the backend or wiring up an iOS app, and honestly, it can make decent looking screens now, but it's still not great at knowing what a real product flow should include unless you give it better context. This is why I've been using Mobbin for over the last year, and I'm really happy that they're sponsoring this video. Mobbin is a product research and design inspiration library with screenshots and flows from shipped apps, so you can understand how real apps handle common UX problems instead of guessing. Previously, my workflow with Mobbin would be to search on the site for specific apps I knew I liked, or look at flows like onboarding, subscriptions, checkout settings, and then manually copy and paste screenshots into my AI coding agents. That's now changed because Mobbin introduced their own MCP, which lets Cursor, Codex, or Claude Code search Mobbin directly and pull in relevant examples while I'm working. So now instead of manually scrolling through Mobbin for 30 minutes, I can ask Codex to research mobile onboarding flows for fitness and nutrition apps that include progress tracking and a paywall. The important part though is that I'm not asking it to copy a screen or magically make my UI look better. I'm asking it to find these shipped examples, break down their structure, and tell me what the patterns are. Then, based on those examples, I can work with my agent to build something that fits my app with way better context before it starts coding. The Mobbin MCP speeds up the research workflow. It helps the agent understand the product category, the flow, the states, the hierarchies, and the details around the screen, not just the visual style of it. Since I've started using Mobbin this way, I've been able to get much more realistic prototypes and handle edge cases in a much more polished way. So if you're using AI coding tools to build apps, I highly recommend checking out the Mobbin MCP with the first link in the description, and thanks Mobbin for sponsoring this video. Now, once you've figured out what you want your app to look like, it's time to start building it. I've decided to use native Swift UI rather than something like Expo because I just prefer making a native iOS app that feels premium, and later down the line, if it ends up being successful, I can always port it to Android. When I'm working on the app, I have Xcode open so I can build the project, but to write all of the code, I jump between mainly Cursor and Codex these days, but I'll occasionally use Claude Code. I'll make a more detailed video about what my coding workflow looks like right now if you guys are interested in that, but when I work with AI, I have multiple agents running at once, all focused on a different part of the app. I use plan modes sort of interchangeably with Opus 4.8 and GPT 5.5 inside of Cursor, depending on how good the output is. I then describe to the agent what I want to build, explain any architecture decisions, and add details like make sure all the text is localized and create a new primitive component for this, etc. I almost never one-shot a massive feature, so API and UI work is usually separate. Because my app interacts with some external nutrition APIs, I like to build the API first so that I can test these endpoints in my local API client and iterate with the agent on things like caching. The way that I found to improve the quality of AI-generated code is only ever asking for 1 or 2 features at a time, depending on their complexity, so that the plan is much easier for me to read and I can call out any issues to ensure the agent doesn't start breaking other parts of the app. Another very important habit I've gotten into is constantly creating new agent-agnostic rules for AI to follow whenever I'm introducing a new pattern into the app, or more frequently, the agent made a mistake. I have rules so my agents will never name things without me confirming it, follow very specific rules about how buttons should behave, and that all text should be localized. You do want to be careful not to bloat your context, so these rules need to be set up so that only relevant agents need to read them. To actually test your app, there's a couple of different methods that you should use depending on how fast you want to iterate or how thorough you want to be in preventing bugs. The simplest way to test is running the app in a simulator, and the benefit is that you can easily screenshot issues and give it to your agent. I've also been using the Xcode build MCP, which lets my AI agents run Xcode, see the build, and oftentimes they'll actually use the simulator themselves to take screenshots and check their work. The downside of testing like this is there's some bugs that you just won't find until you're testing on an actual device. And for certain features like vibrations and just understanding how does your app actually feel to use, you can only do this on a real device. If you connect your phone to your laptop directly, you can actually preview the app on your phone, but the best way to test it and catch critical errors is to archive your product and distribute it to App Store Connect so you can download a test flight build. A test flight build is pretty much the closest you'll get to it being a release version. You or anyone you invite to test your app can download the app and start using it in what is essentially a production environment. Here's where you're going to figure out if your APIs are hooked up properly, if that's relevant to your app, or if you set up things like review prompts and subscriptions properly. Once you've done enough testing that you think your app is ready to be submitted to the App Store, this is where the hardest part of the process comes. Apple is very strict with what apps it allows on the App Store and what you're allowed to do inside of them. My advice is to get an app version submitted to Apple as early as possible, because your first submission is always going to be rejected, so you want to figure out what's wrong as soon as you can. The important thing though is that your app actually has to be usable, because that is a criteria that Apple reviews on. Don't ship any half-baked features or placeholder UI, only submit fully completed features that work end to end. It took me about a week back and forth with Apple where every additional review was another about 24 hours to get a response. I was denied over and over again for a number of reasons. The first was related to my app's privacy policy. I used Posthog to track how users use the app, and I mentioned that in the related policy. Apple is actually going to read this and ensure that your app is behaving exactly like how you describe and is asking for the proper permissions. Because my privacy policy contains something along the lines of we track users, Apple requires that you have that tracking pop up, whether or not you actually do track your users. So make sure your privacy policy is accurate to what your app does. Another really tricky issue I ran into was the final step of onboarding would constantly crash because the paywall wasn't retrieving the app's subscriptions. I'm using RevenueCat right now to help set up subscription management, but I didn't realize that Apple reviews your app in a special sandbox mode, but my app was trying to pull just the regular production subscriptions, and so it was completely failing in this sandbox mode that I had never tested. Once I actually got the paywall working, they then denied me because it wasn't clear enough how much the user is actually going to be charged for subscribing. There's a lot of things to watch out for when you're going through this process, so I actually wrote a checklist that will make sure your app is following all of Apple's guidelines properly before you submit, so I'll leave a link in the description if you want to check that out. Once the App Store review process was completed, I was able to release my first iOS app to the App Store, and that's really the easy part these days because you're not going to magically get users just because your app is available to download. You do need to do actual marketing, which is honestly something I've never really done before. And this is where I realized that I was building the wrong app because I just didn't want to talk about this app because I wasn't a real user of it. I'm still trying to learn how to market my app and actually get users, but I have a strategy that I'm gonna start putting into action, and I'll be documenting that whole process on this channel. So that's where I'm at in my app building journey. If you only take away one thing from this video, it's that actually shipping the app is the easy part, but knowing what the right thing to build is and how to get that in front of real users is the difficult thing you should be spending most of your time on. If you're about to ship your first app, that checklist I mentioned is everything I wish I knew before I submit it to Apple. There will be a link to that in the description. Thanks for watching, and take care.